This is what we're going to be making today. It is a simulation of firing projectiles at random angles and velocities. And it serves as a great introduction to how you can use physics to help you make art, which just opens up a whole world of possibilities. So let's get into it. I'm going to start as usual with just a blank canvas, as we've done in our other projects. But let's do the physics first. I'm going to use this type to record the position of the projectile over time. The inputs to firing the projectile is an initial velocity, it's just a number, and an initial angle that we fired it at. That's all we need to determine a trajectory, because we're always going to start at 0, 0 and then shoot the thing. Now, you may remember from physics that there is a constant downward acceleration. And ignoring air resistance, there is no acceleration in the horizontal direction. So the horizontal velocity of a projectile like this stays constant during its flight. And the vertical velocity changes based on that constant acceleration. Just approximate it to 10. So let's start by getting those velocities. I'm making this a const because, as I said, this doesn't actually change over time if we're ignoring air resistance. And that's, just the horizontal portion of the initial velocity based on that angle. And the y velocity is just do the sine instead of the cosine. This one is not a const though. This is changing over time. And then basically what we want to do is take small time steps and track where the particle is going to be. Of course, we're going to start at 0, 0, and then the x coordinate of the particle is just what it was at the last time step, plus the velocity times the time, and same for the y coordinate. And we're going to just keep looping until we hit the ground. So if the y coordinate is less than 0, then we're done. And this is what I was just describing. We need some time stuff here too. Let's see how that works. So the x-coordinate is just what it was before plus the velocity times the time step. Same for the y-coordinate. This just means position is what it was before plus however it's changing. That's the definition of velocity. And the only tricky part here is updating the y velocity. But it's not that tricky. It's just, this is the definition of acceleration. It's how much the velocity is changing. So we just take the acceleration and multiply by the time step, and that's how much the velocity has changed. So both these things are just definitional. Velocity is how much the position is changing, and acceleration is how much the velocity is changing. And I want this to return an array of positions, just how the projectile is moving through space. Okay, awesome. So if we call this with an initial velocity and initial angle, we should get back an array of positions, and we'll quit adding new positions to that array once the projectile hits the ground. Let's go ahead and just do a sanity test here. So 45-degree angle with a velocity of 100. Let's just see if we got something reasonable. Yeah, I mean, that looks fairly reasonable. Okay, the next step is actually drawing that trajectory now that we have it. And so this is just going to take in the trajectory that we generate in the fire projectile function and draw it on the canvas. We already have all the stuff, so I'm going to delete this in a second, but I want to see what else it generates. So again, we already do all this stuff below. But go ahead and set the line that we're going to be using. I'm going to just make it black for now. And then loop through all the points in the trajectory. Do a translation on the Y, because again, I said we're starting at 0, 0 and going upwards as we fire it. I talked about this in a previous video, but the way this canvas package works is 0, 0 is actually the top left of the canvas, and the Y coordinate increases as you go down. So we just flip this over to get the projectile to start from the bottom left and go up. Yeah, and then if it's the first one, we do move to, otherwise we just continue the line. So I think this should work. We can test this pretty quickly. So we have a trajectory, and now let's just draw the trajectory. Let's see what this looks like. Didn't get anything there. Why are we not getting anything here? Because we're drawing the picture right there. So let's adjust this. And hopefully we get something now. Awesome. And let's make sure this is working. So that's at a 45-degree angle. Let's make the velocity smaller, so we should get a shorter arc. Great. And let's bump it back up to 100. But let's fire this at a steeper angle. Nice. And go even steeper. Great. All right. Now the goal is, let's get multiple of these trajectories now that we can draw one. So I'm just going to loop through. Let's do 10 for now. And let's get a random angle. And a random velocity. And then create the trajectory and draw it. So now we should see 10 random trajectories. Awesome. Maybe these values are a bit off. The velocities look like they're much too high. Let's damp that down to something more reasonable. So the max velocity now is 100. There we go. That's nice. The final thing I want to do is create an animation like this one that I showed you in the beginning. And this is actually not much harder than generating these images. All I do is create snapshots periodically and create images, and then stitch those images together. So let me show you what I mean. Go ahead and create a new folder to store all these images. And then instead of drawing one image at the end, we're going to draw an image every time we update the line on one of these trajectories. And I don't want them all named the same thing, otherwise we would overwrite this file each time. So let's create a variable to hold which image we're currently on. And then include that in the name. I'll put these in the images folder. So this will just create a whole bunch of images named in this pattern. And it's taking a while because this is probably something like 1,000 images. But we can start looking at them, so you can see just a whole bunch of images. And just updating as we go through drawing these projectiles. Actually, it doesn't seem to be at each point. There might be something wrong here. We're not doing the stroke. So we're only doing the stroke outside the loop. We want a stroke at each update. So let's do that again. And this is just going to overwrite the ones we created last time. There we go. So now we can see basically each image is another step in our simulation. And then all we have to do is stitch these together with FFmpeg, which we can do like this. And that should create an output file that has our simulation. All right, that's it. That's an introduction to how to use physics to make some images, and also how to create animations. So go ahead and check out the code. I'm going to link to it and play around with these ideas for yourself. See you next time.